Everybody is talking about building AI agents. It's the new hot thing, but what very few people are talking about is how to build them so they don't just completely fall apart the second they hit the real world. So let's get into it. Let's dive into the system design blueprint that separates a cool-looking demo from an AI agent that can actually survive and thrive in production.
And to kick things off, here's a pretty wild fact. A massive 70% of AI agent projects fail the moment they're deployed to production. Yeah, you heard that right, 70%. It's a huge number, and it tells you something really important. Building the agent is maybe half the battle. The real challenge? Making it actually work.
And that really is the million-dollar question, isn't it? How do you build one that works? The answer isn't just about crafting clever prompts or finding the perfect model. It's about solid, foundational software engineering. It's about system design. And in this explainer, we're going to walk through the exact architectural patterns that make all the difference.
All right, here's our game plan. First, we're going to figure out why so many of these agents fail in the first place. Then we'll build our solution from the ground up, starting with a solid microservice foundation. After that, we'll teach it to handle the chaos of real-world traffic, give it a reliable memory, and finally, set up the systems to watch it, learn from it, and make it better over time.
So, first things first, why the huge failure rate? Well, the number one culprit is actually a pretty old-school approach to building software, cramming everything into one giant interconnected application. You've probably heard the term for it. It's called a monolith.
And this, right here, this gets to the very heart of the problem. A monolith is basically a house of cards. One tiny bug, a single faulty line of code in one small function, can bring the entire system crashing down. The whole agent, just gone. The modern solution is to break that agent into smaller, independent, specialized pieces called microservices. Think of it like this. Netflix isn't one giant program, right? It's a whole symphony of small services working together. That mental shift is the absolute first step.
Okay, so we've done it. We've broken our agent into all these independent services, one for understanding language, one for planning tasks, another for using tools. But now we have a totally new problem. How in the world do we manage all of these moving parts when things start to scale up?
Well, the answer starts with something called containers. They solve that classic developer headache, it works on my machine problem, by packaging each service up with everything it needs to run. But when you have hundreds of these containers, you need a conductor for your orchestra. And that's exactly where a tool like Kubernetes comes in. It's the system that automates the entire life cycle of all those services.
And this is exactly why Kubernetes is so incredibly powerful. It doesn't just run your services, it runs them intelligently. If you get a sudden spike in traffic, it automatically scales up to handle it. If one of your services crashes, it self-heals by just restarting it. It figures out where to put everything and makes sure all the services can find each other. This right here, this is the bedrock of a reliable system.
Now the key here is you don't try to boil the ocean on day one. You don't jump straight into this massive, complex setup. You evolve into it. You start with a simple, containerized prototype just to prove the idea works. Then you move to a staging environment to test how the pieces coordinate, and only then do you graduate to a fully orchestrated production-grade cluster. It's a clear, manageable path forward.
Okay, so our services are up and running, they're orchestrated, and they're stable. But now they have to face their next great challenge, the absolute chaos of real-world internet traffic. It's unpredictable, it's spiky, and it can be absolutely brutal. And we're not talking about a small trickle of requests here. A real production system might be handling, say, 50 tasks 1 minute, and then suddenly need to scale to over 5,000 tasks the next, all without even breaking a sweat. So, how do you build a system that can actually do that?
You do it with layers. It's a multi-layer strategy. First, you have an API gateway. Think of it as the bouncer at the front door, handling security and basic routing. Then, inside, a smart load balancer acts as a traffic cop, intelligently directing requests to the right place, maybe sending a tough task to an agent with a powerful GPU. And finally, a service mesh acts as a safety net, automatically isolating any service that starts to fail so it can't cause a chain reaction and take down the whole system.
But what about the tasks that take a few minutes, not milliseconds? You can't just make a user stare at a loading spinner forever. The solution is asynchronous communication, using what's called a message queue. Just think of it like an internal post office. One service drops off a message, a task, and another service picks it up and works on it when it's ready. This completely decouples the services, guarantees no task ever gets lost, and gives your entire system incredible patience.
So our agent is now resilient. It's scalable. But to be genuinely useful, to be truly intelligent, it needs one more thing. It needs to remember. It needs context, it needs knowledge, and it needs a really sophisticated way to manage all of that information. Honestly, there's a perfect way to think about this. An AI agent without memory is really just a stateless, very expensive API call. That's it. It forgets everything the second a task is done. It can't learn, it can't personalize anything, and it definitely can't handle complex, multi-step jobs. Memory is what transforms it from a simple tool into a true agent.
And here's a pro tip. Production-ready systems never ever use a single, one-size-fits-all database for memory. Instead, they use a layered approach. You'll have super-fast in-memory databases like Redis for short-term stuff, like the current conversation. Then you have powerful vector databases to manage long-term knowledge. And of course, traditional databases for all that structured data, like user profiles and logs.
And when we dig into those vector DBs, the choice you make has real trade-offs. For instance, Pinecone is a fantastic choice if you just want to get started fast with a fully managed solution that just works. But if your agent needs to understand images or audio, not just text, you'd probably look at a multimodal expert like Weaviate. On the other hand, if your number one priority is raw performance and keeping costs down, and you've got the engineering chops to manage it, then something like Qdrant might be your best bet. It's all about matching the tool to your specific job.
Okay, we've built it, it's scalable, it's resilient, it has a great memory. We're done, right? Not even close. A production system is a living, breathing thing. And to keep it healthy, you have to be able to see what's actually happening on the inside.
The technical term for this is observability, and it's non-negotiable. AI agents are incredibly complex systems. They make decisions, they call different tools, they interact in weird ways. Without the ability to see why an agent did what it did, or which service call failed along the way, you are flying completely blind. Debugging becomes an absolute nightmare.
So, achieving real observability means taking a few key actions. You need to be evaluating the quality of the agent's output in real time. You need to store detailed, structured logs so you can trace problems backward. You have to capture every single LLM call and decision. And critically, for your most important tasks, you absolutely need a human review loop. It is often the only way to reliably catch subtle errors and provide the feedback that helps the system get smarter.
And that brings us to the final piece of the puzzle. Your agent is going to change. You're going to add new tools, update the models, fix bugs. A CI/CD pipeline, that stands for continuous integration and continuous deployment, is the automated machinery that lets you safely test and roll out all these changes without breaking anything. It's the engine of continuous improvement. So there you have it. We've gone all the way from a fragile idea to a resilient, scalable, and self-improving AI system. This is the blueprint. But it really leads to one last thought. Once you've built all this, the journey isn't actually over. In fact, in a lot of ways, it's really just beginning.